Somewhere out there, two invisible objects are spiraling toward each other, closer every second. And when they finally collide, nothing explodes. The very first collision we ever detected released, in a fraction of a second, more power than every star in the observable universe combined. That signal crossed over 1 billion light years, arrived as a sound barely a second long, and it proved black holes crash together in more than one way. This is every way a black hole can collide, with another black hole, with a dead star, even with another galaxy's monster, and why each one sounds completely different. None of this comes from a telescope. The detectors that catch these collisions don't take pictures. They listen for space itself stretching and squeezing. Gravitational waves come from any mass that accelerates. Even you, walking across a room, technically make them. They're just too faint to ever notice. A wave strong enough to detect still squeezes space by less than the width of a proton, across a detector miles long. Space is rude like that. Every one of these gets recorded as a waveform, a little squiggle of data. Different collisions leave completely different squiggles. 3 main flavors show up in that data. Black hole meets black hole meets dead star, and monster meets monster at the centers of galaxies. Type 1. 2 black holes, roughly the mass of a star, locked in a death spiral. This is the collision astronomers hear the most. Every orbit, the pair leaks a little energy away as gravitational waves. That loss pulls them closer. Closer orbits leak faster. It's a spiral with no brakes. In the final moments, the spiral speeds up violently, from about 1 orbit a second to hundreds of orbits a second, right before impact. Then their event horizons touch, merge, and ring. And for a heartbeat, this newborn black hole is the most violent single object in the observable universe. In their last orbits before merging, these black holes move at a meaningful fraction of the speed of light, nature's speed limit, and they're practically tailgating it. 2 black holes colliding equals a blinding explosion of light. 2 black holes colliding equals complete, total darkness. Let's swap one of those black holes for something almost as extreme, and the universe suddenly turns the lights back on. Type 2. A black hole colliding with a neutron star, the collapsed corpse of a star that wasn't quite massive enough to become a black hole itself. A neutron star packs more mass than the sun into a sphere the size of a city. A teaspoon of it would outweigh a mountain. If the black hole is much bigger, it swallows the neutron star whole, in one gulp, no mess. If the masses are closer, it shreds the neutron star apart first. When it shreds first, that debris flares into a kilonova, and inside that fireball, the universe forges gold, platinum, and nearly every heavy element you own. In 2017, one of these events became the only collision ever caught in both gravitational waves and light at the same time. Proof, all at once. Remember the collision that stayed pitch dark? This one lit up the sky and helped seed the periodic table. Black holes collide in completely different moods. Both of those involve objects a few dozen times the sun's mass, at most. Now multiply that by 1 million, sometimes 1 billion. Type 3. Supermassive black holes, the kind sitting at the center of nearly every galaxy, including ours, crashing into each other. This starts when 2 entire galaxies collide and merge. Their central black holes get dragged toward each other by the gravity of everything falling inward around them. Getting close is easy. Getting the rest of the way is a genuine open question in astrophysics, one nicknamed the final parsec problem. A single supermassive black hole can weigh billions of times what our sun does. When 2 finally merge, it isn't 2 objects colliding. It's 2 solar systems worth of gravity. That merger vibrates space-time far too slowly for ground-based detectors to ever hear. Catching it will take an observatory the size of a solar system, floating in space. In 2023, astronomers found the next best thing, a faint, constant background hum in the timing of distant pulsars, likely coming from countless supermassive mergers happening across the universe at once. The dark collision was invisible. The bright one forged gold. This one might be humming through the galaxy right now, and we can't even point to where it's coming from. Here's the part that changes everything. All 3 of these, stellar, mixed, supermassive, follow the exact same 3-act pattern. Every merger ends the same way. The newborn black hole rings like a struck bell, settling into a perfect sphere. That ringing is the sound detectors actually hear. Bigger black holes ring at a lower pitch, over a longer stretch of time. Smaller ones ring fast and high. Mass literally tunes the note. That's how scientists tell them apart. Not by looking, but by the shape of the wiggle in the data. Each type leaves a completely different signature. So a stellar merger chirps upward in a fraction of a second, almost too fast to notice. A supermassive merger would groan for years, in a note too deep for any instrument we've built to catch yet. So here's your answer. Black holes collide in at least 3 completely different ways, and every single one is really just the same cosmic bell, tuned to a different size. Shift that first signal into a range human ears can hear, and it sounds like a single rising whoop. Up in pitch, up in volume, then silence. On September 14th, 2015, that whoop showed up in the data before scientists had even finished calibrating the detectors. Nobody quite believed it. It looked too perfect to be real. Multiple observatories, separated by thousands of miles, have to catch the same signal within milliseconds of each other before anyone can confirm it's real and figure out which patch of sky it came from. By now, observatories have caught signals from hundreds of these collisions, and every single one adds another note to the same growing symphony. Some of the gold in the device you're holding right now was very likely forged in a collision exactly like this one. A black hole devouring a dead star, long before Earth even existed. Zoom out further, and these mergers aren't just violent footnotes. They're part of how galaxies, including the one you live in, grow and eventually settle down. It's also probably the only way supermassive black holes get so big in the first place. Merger after merger, generation after generation, stacking mass on top of mass. A space-based detector built specifically to finally catch supermassive mergers directly is already in development, targeting a launch sometime in the 2030s. Collisions like these have been happening across the universe for billions of years, in total silence, completely unnoticed. And it's only in the last decade that we finally built something capable of listening. Subscribe for what happens in the final second before you'd actually fall into a black hole, and why, from your point of view, that second never technically ends.